This is the workout of the problems on the test review sheet for sections 12.3 through 12.7 and 14.3. And then there's a little bit of review at the end. There's a problem from chapter 4, one from chapter 8, and then one from chapter 9. So I'm just going to go through every single problem on this review and just talk you through how you work out these problems. Your test looks a lot like this review sheet. So let's get started. In number 1, 2, and 3, we're dealing with this triangle called ABC. So let's just draw a triangle ABC, right triangle. And we're told that B is a right angle. So that means we can call these other two acute angles however we want to. The only thing that we have to be careful with, if we call this angle A, then this needs to be side A, and this needs to be side C, and this will be side B. Okay, so just remember that the sides are opposite the angle. Okay. What else do we know? B is a right angle. The side AB, in this case, is measured at 30. And we're told that secant A is 5/3. Well, do you remember that secant is the inverse of cosine? So if secant A is 5/3, that means cosine A is 3/5. Okay? Remember that secant is just the inverse function for cosine. So we can go ahead and write down our answer for the first problem. The first question is, what is cosine A? And we just found that. It's 3/5. Okay, to find these other trig ratios, especially when we're looking for sine, we're going to need to know the hypotenuse. And so let's think about this ratio that we're given, secant A. Remember, secant we can think of if cosine is adjacent over hypotenuse, then secant is just the inverse of that, hypotenuse over adjacent. Well, some people looked at this and said, now wait a minute, if hypotenuse over adjacent, that would make this 5, and isn't the hypotenuse supposed to be the longest side of the triangle? And the answer to that is yes. So if this adjacent side is represented as 3, but we're told that it's actually measured at 30, then what we're dealing here with isn't a fraction that's been reduced. Okay, so this fraction, if the denominator of this fraction is 30, can you see that really this was the fraction originally 50 over 30, which reduced into 5/3. So the hypotenuse turns out to be 50. And now we're going to use the Pythagorean theorem to come up with this missing side so that we can get the rest of our answers. All right, so the Pythagorean theorem is, in this case, the hypotenuse squared, 50 squared, equals 30 squared, plus this unknown side, we'll just call it A squared since it's the side opposite angle A. All right, so now you're going to use your calculator, and I would just do, since we're going to be subtracting, I would just do 50 squared minus 30 squared. That's 1600. That's A squared, but if you do the square root of that, the square root of that number would give you 40 as A. So we've just determined that this side, either known as BC, or you could think of it as side A, it measures out at 40. All right, so now we're good to go with finding any trig ratio we want to. So let's go ahead and answer this part for sine A. Looking out from angle A, sine is opposite over hypotenuse. You really need to drill in your head what all of these trig ratios mean. Cosine is adjacent over hypotenuse. These are all in your notes for section 14.3. So the opposite side for angle A is 40. The hypotenuse, of course, is 50, but we need to reduce that and call it 4/5. Okay, now let's figure out what tangent C is. All right, we're looking now out from angle C. Tangent, the ratio is opposite over adjacent. So for angle C, the opposite side is 30 and the adjacent side is 40. So reduced, that would give us 3/4. Okay, so once again, when you're running into these, you're given a trig ratio that represents a reduced fraction. Maybe you want to think of it in this way. If you think of 5/3, okay, and remember secant is, as we've written here, it's hypotenuse over adjacent. But you're told that the adjacent side is equal to 30. Then just think of this as like a proportion. What would you multiply by on this bottom part, the denominator, to get 30? Then you need to do the same thing to the top. And that might also help you figure out when this is a reduced fraction, how you get that actual measurement, okay, in this case for the hypotenuse. Just a suggestion, some people were able to see this for what it was, a reduced fraction, so they could reason through what the numerator is, but here's another way of thinking about it. All right, so let's move on. Numbers 4 and 5 deal with the triangle DEF, and angle F is a right angle. All right, so I'm going to draw two different right triangles, one for each of these problems. Okay, F is the right angle, so I'm just going to call this angle D and this angle E. Okay, in number 4, we're told that side E is 6. Well, if this is angle E, then directly across from angle E is side E. If F is 10, F, the side F, is directly across from angle F. So we're given the hypotenuse of this right triangle. What we don't know is side D. So our final answer, we're going to be finding side D, we're going to be finding angle E, and angle D. Okay, well, let's work on side D first, and we'll use the Pythagorean theorem again. So the hypotenuse, which is 10 squared, equals one leg squared plus the other leg squared. Okay, grab your calculator. And I'm going to subtract 6 squared from both sides, 10 squared minus 6 squared. That's 64. And then I'm going to do the square root of both sides to get my side D, which is 8. All right, so there's one of my answers. And to give me something to look at, I'm just going to go ahead and show that this side is now equal to 8. All right, so now let's work on either one of these angles. It doesn't really matter which way you go first. Since I've got E listed first, let's just go ahead and try to find angle E. And I just pick a trig ratio to use. For example, I could use sine, because for sine of an angle, that means opposite over hypotenuse. So let's just write it in equation form. Sine angle E is equal to, in this case, the opposite, which is 6, over the hypotenuse, which is 10. Now I'm trying to find angle E, so it's like solving this equation for E. So I'll just show it this way. I'm going to do the inverse of sine on both sides of this equation. Just to show you how I'm getting this answer, this is technically what's happening. Now I'll use some color to emphasize. Okay, it's like undoing the sine of e with the inverse of sine. And the result of this, e, will be found by just doing this in my calculator. I literally am going to do the inverse sine, so do sine or second sine on your calculator for the inverse, and then just do 6 divided by 10. So let's do that now, and let's see if we get the same thing. So I'm going to do second sine for the inverse sine, and then in the parentheses I'm going to do 6 divided by 10. And that decimal is 36.869896765, but we're supposed to round to the nearest tenth. So we're going to call that 36.9 degrees. All right. So at finding angle D is going to be pretty easy then, because I can just use my rule of the sum of the angles of a triangle total to 180 degrees. So let's just start at 180 and subtract the angles we know. All right, we now know that angle E is 36.9 degrees. And doing this in my calculator, 180 minus 90 minus 36.9 gives me 53.1 degrees. And so that's my final answer for number 4. Okay, let's work on number 5. So let's just draw another right triangle. Okay, and again, we're told that F is the right angle, so we can go ahead and do, this is D and this is E again. This time I'm given the measurement for D, so if this is angle D, then this is side D. The side is opposite the angle. And if E, side E is 12, well, that's opposite angle E over here. So this time I'm looking for F, which is really the hypotenuse. So you can think of it this way. Since it's called F, I'm just going to say F squared is equal to 12 squared plus 10 squared. Okay, 12 squared plus 10 squared, that's 244. And then to solve for F, this is F squared, so I need to do the square root of both sides. And again, rounded to the nearest tenth, my calculator reads 15.62049935. So to the nearest tenth, it would be 15.6. So I'm just going to make a little summary box up here to show my answer. All right, so we know the missing side, and now let's see if we can find the missing angle measurements. Okay, I'll be a little different. This time let's approach it from angle D's perspective. So remember, I do not want you to use an approximation or a rounded decimal in your trig ratio. So I am not, for example, if I'm approaching from angle D, I'm not going to do sine, because that would involve opposite over hypotenuse, so I would have to use that rounded decimal. So I want you to get a little more precise than that. Now, if you approached from angle D's perspective and you use tangent, that would be fine, because tangent is opposite over adjacent. All right, so let's do that. Let's set up an equation, and maybe I can move this over. So a little bit of room. All right, so let's work on angle D by using tan D is equal to opposite over adjacent. Okay, again, we're looking out from D. So once again, I won't show this whole thing, but to solve for D, that means I'm going to do inverse tangent on both sides. All right, so grab your calculator and do secant tan, and then with parentheses, we'll just do 10 divided by 12, or maybe reduce the fraction. It's okay, it won't matter. So tan negative 1 inverse tangent of 10/12 gives me the decimal 39.80557109. So again, we're rounding to the nearest tenth, so we're going to say that's 39.8 degrees. All right, angle D, 39.8. And that makes finding angle E easy because we just, again, start with 180 degrees, subtract our right angle, subtract angle D, and in our calculator, 180 minus 90 minus 39.8, 50.2 degrees. And those are your answers for problems number 4 and 5. Okay, let's work on this word problem number 6. And I always recommend that you sketch out this right triangle that's being formed with the ladder and the wall of the house. Okay. So we have this 25-foot ladder that just reaches the top of a house. Okay, well, if you're going to use a ladder, ladders will lean on the house. Okay, so this line here would be my ladder leaning against the wall of the house. So we're actually asked to find the height of the house, so this is unknown to us. The ladder, which is leaning, is 25 feet. Okay. And what else do we know? Where the ladder reaches the house, as it's leaning on the house, it forms an angle of 41.5 degrees with the wall of the house. So here's the wall of the house, here's my ladder. Where they come together forms an angle of 41.5 degrees. So how are we going to find this missing side? Okay, well, looking out from this angle, I'm looking for the adjacent side of this angle. I know the hypotenuse of this right triangle. So the ratio that deals with adjacent and hypotenuse is cosine. So I'm going to use cosine of the angle 41.5 degrees is equal to adjacent, which is what I'm looking for, divided by hypotenuse. Okay, so to solve for x, I'm just going to multiply by 25 on both sides of this equation. And my left side of the equation will be literally what I key into my calculator to get my answer. So let's do that. 25 and then cosine, parentheses, you'll have 41.5. The decimal form of that is 18.7238, and we're told again to round to the nearest tenth. So we're going to say that this height of the house is approximately 18.7 feet. And that's my answer. All right, let's move right along. In number 7, we're given this triangle XYZ, and Z is a right angle. Okay, so let's just sketch that. There's Z, so I'm just going to call this X, and this is Y. We're also told that tangent X, so looking out from angle X, and remember that tangent is the ratio opposite over adjacent. Okay, so from angle X, the opposite side, which is the top number of this fraction, will be 8. And looking out from angle x, the adjacent side, which will be the bottom number of this fraction, will be 15, which means that I do not know the hypotenuse. So once again, I'm going to use the Pythagorean theorem. And I'm looking for z, side z, z squared is equal to 15 squared plus 8 squared. Okay, grab a calculator. So that's 289 for z squared, but I need to find z, so I'm going to do the square root of that. And you get z is 17. All right, so now that I know the 3 sides of the triangle, it's pretty easy now to look from angle y's point of view, and let's find out what sine y is. Well, remember, sine is opposite over hypotenuse. So for this angle y, the opposite side is 15, and the hypotenuse of the right triangle is 17. And that's your answer for number 7. All right, very good. Let's move on to number 8. For number 8, we're asked to find mean, median, and mode. And here's my data set. So remember, to find the mean, it's the sum of all of these numbers, and then divide that sum by the number of terms in your data set. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers in our set. So let's just grab our calculator and start adding. 41 plus 41 plus 44, and just keep on going. 46, 47, 48, 49 twice, 50, 52, 53, and 54. Okay, so we should have gotten that sum is 619. And now when you take that sum and you divide it by the number of terms in our data set, which we said were 13, that's 47.6153, but rounding to the nearest hundredths, we're going to say the mean is 47.62. Right? Median refers to the middle number, and so some people will go through this little process, just start marking the numbers off from the beginning to the end and work your way toward the middle. Right? So marking them off in pairs like this, and it looks like 48 is our middle number. And mode refers to the most commonly occurring values, and it is possible to have more than one mode, and that's what happens here because the number 41 appears twice and the number 49. So actually we have 2 modes, and we just list them each, 41 and 49. Okay, now we'll do our box and whisker plot with this data, and another name for the box and whisker plot is the 5-number summary, because we're going to basically accentuate 5 numbers. We need the overall median, which we've already found is 48, and you can think of that number 48 as a divider that separates our data up into 2 smaller groups of 5, or 6 actually. So I have a group of 6 on the left side of 48, and I've also got a group of 6 on the right. So this middle number for the left group of 6, which would be 44.5, that's called Q1. The overall median, of course, is called Q2. And then I need to find the median for this right group of 6. And as you can see, that is 51. and that's called Q3. So the box and whisker plot will involve points or dots above our number line for Q1, Q2, and Q3, and then we'll also show lines drawing out to our smallest value and our largest value. So let's just go ahead and draw a number line. You need to just come up with some number line, not just these numbers. Just make up a number line that has a certain interval. You're just incrementing by some number. In this case, I'm doing increments of 2. All right, let's work through this. And I've got a number line now where I will plot these 5 numbers. Okay, I'm going to plot these 5 numbers on my number line or above my number line. So 44.5, let's just change color. Here's 44, so I'm just going to estimate 44.5 to be about right there. All right, and then of course 41, we can go ahead and put it on here. 41 is right in between. 48, which is my Q2, of course it's right there. 51, which is Q3, and then the highest value. Okay, so for Q1, 2, and 3, I'm going to draw lines through them. They get vertical lines, and then I'm going to draw a box. For the whiskers, we just come from the box to the small value and to the large value, and that is a box and whisker plot for this data. 10 and 11 say to find the range and the interquartile range. Well, range is the difference between the largest number in the data set and the smallest number. In this case, that's going to be 13. Interquartile range is Q3 minus Q1. So in this case, that's going to be 51 minus 44.5. And when you subtract these, you get 6.5. And that takes care of problems 8 through 11. Okay, let's do this standard deviation problem, and this is a little process that will lead us to the standard deviation formula, which I'll just go ahead and write in here for you. Here's the formula for standard deviation. It's, in just a minute, we're going to have a, let me back up just a minute. We're going to have a column that is labeled x minus x bar squared. And we're going to find the sum of that column, and that will be the numerator of this formula. The denominator will be the number of terms, which in this case is going to be 5. Okay, so I'm just going to set up a little table with column headings. X refers to the actual numbers in the set. There's no need to arrange these if we're just doing standard deviation. You can just write them down just like they're given. Okay, and then our next column will be what is the mean. So remember, to find mean, we just add these up. 48 plus 53.2 plus 52.3 plus 46.6 plus 49.9, and we get 250. And 250 divided by the number of terms, which is 5, gives us a mean of 50. All right, so instead of writing that 4 more times, I'm just going to show this whole column is filled with the number 50. Okay, the next column should read the original number in my data minus the mean. Okay, so just use your calculator and go down the list and do the subtraction. 48 minus 50 negative 2, 53.2 minus 50, 3.2, 52.3 minus 50, 2.3, 46.6 minus 50, negative 3.4, and 49.9 minus 50, negative 0.1. Okay, the next column will be these numbers that we just came up with, but squared. So we're just going to go through and square each one of these numbers. Well, negative 2 squared, of course, is just positive 4. Remember, all of these, when squared, will be positive. All right, so 3.2 squared, 10.24, 2.3 squared, 5.29. If you want to, you can just put in positive 3.4 squared because you know it's got to come out positive, and that way you won't maybe accidentally put a negative number in this column. But that's 11.56. And then 0.1 squared is 0.01. So this is the one column we need to find a sum for. So let's add these up. And I'm just running through them, just like maybe you are. And we get 31.1 as the sum. All right, so now let's just use the formula for standard deviation. This is the symbol for standard deviation. It's lowercase signal. The numerator underneath the radical will be 31.1. The denominator underneath the radical will be the number of terms, 1, 2, 3, 4, 5. So in my calculator, I'm just going to do all of this at once. I'm going to do the square root of the fraction, 31.1 divided by 5. Close my parentheses. And that comes out to be 2.49399278.3, but the directions said to round to the nearest tenth, so that would be 2.5. So there's actually two answers here. We found the mean, which is 50, and the standard deviation, approximate 2.5 after rounding. All right. The numbers at the 20th and the 80th percentiles for this data set. So when you're finding a percentile, you need to first of all order the data, and I will do this for you on the test, but these unfortunately are not placed in order from lowest to highest, so make sure before you, anytime you do percentiles, the numbers need to be ranked in lowest to highest order. So let's run through this. We should have 168, and we'll just mark them off as we go. We got 170, okay, and 172. I'm just checking to make sure I don't have another one. 174, okay, 176. I got another 176, 178, 180, okay, 182, 184, 186, two of them, 188, 190, and I don't think I'll be able to squeeze that in. I'll just put 198 right here. Okay, so I should have 15 numbers. I'm just going to count, make sure I got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We're good. So to find the number that's at the 20th percentile, take 20% in decimal form multiply by the number of numbers, which we said is 15, and that's 3. Well, the number that's at the 20th percentile should be the number that's better than the first 3 numbers in our list. So you could look at it this way. You would basically just mark the 4th number in the list. So my answer for number 13, the 20th percentile, would be 174. To find the number at the 80th percentile, then do 80% decimal form times 15. You get 12. All right, so the number that's at the 80th percentile should be the number that's better than, just to the right of, the first 12 numbers in the list, or in other words, the 13th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the number that's sitting at the 80th percentile is the number 188. All right, moving right along. 15 through 17, we have this poll of 630 randomly selected high school students. 435 plan to attend college. The sample proportion is the number that plan to attend college divided by the total number of students that we polled. So to find the sample proportion, we're just going to do this little division problem. Number that plan to attend divided by all the students that were polled, and we'll just round this to the nearest percent. So grab your calculator, do 435 divided by 630, and round it to the nearest percent, you get 69%. Now the calculator says 0.69, but remember that's decimal form and we want the percent form. The margin of error, well, let me show you the margin of error formula and then we'll use it. Margin of error is equal to plus minus 1 over the square root of n. N is the number of people that we polled, in this case 630. So to find margin of error, I do plus minus 1 over the square root of 630 in my calculator. So let's do that. 1 divided by square root 630. My calculator says 0.0398, and then that's the decimal form. So we're just going to go to the nearest percent, and that would be 4%. Moving the decimal point 2 places to the right, and then just rounding to the nearest percent. So this interval, or you might think of the word range, that is likely to contain the true population proportion. We think that 69%, or based on our calculation, 69% plan to attend high school, but that doesn't account for a margin of error of plus minus. Ooh, almost forgot. Don't forget plus minus. Very important. This 69% doesn't account for the fact that since we didn't poll every single high school senior, we only did a sample, there's some error involved. And so to build this range from 69%, accounting for the margin of error, then just think of 69% minus 4% and 69% plus 4%. And that gives us confidence that our data is correct within this interval. Okay, so that would be my final answer for number 17. Number 18 says a data set has a z-score of 4, value of 55, mean of 35. So you're going to need to know the z-score formula for this test, and here it is. Z-score is equal to value minus the mean divided by the standard deviation. Okay, so we are told what z-score is. It's positive 4. The value is 55. The mean is 35. what we're asked to find is standard deviation. So we're going to solve for this standard deviation, so you can think of multiplying by it on both sides. Dividing by 4 gives us a standard deviation of 5. So that would be my final answer for number 18. Just make sure you know what the z-score formula is. Okay, determine the sample size that produces a margin of error of plus minus 6%. Well, once again, we need to use the Mo formula, margin of error. Just repeating it from what we looked at earlier. But this time, we know what margin of error is. It's 6%, and in decimal form, that's 0.06. What I don't know is n, the sample size. Now, I intentionally left off plus minus in this formula because sample size refers to a number of people that we will have polled, and there's no way to poll a negative number of people, so this has to be a positive result. So at this point, I wanted you to see the Mo formula, but we're really not going to need the plus minus part. All right, so if I'm solving for n, currently n is in the denominator. Sure would be nice if it were in the numerator. Well, that's easy enough to do, because if I flip both sides of this equation, whatever I do to one side, just do to the other, mathematically, all I did was raise both sides of this equation to the -1. Now it makes it pretty easy to find out what n is. To remember, in our past lessons, we undo doing the square root of something by raising to the second power. Okay, and so I discovered that some people are doing this and then squaring that, but you'd be better off just doing all of that in your calculator. Just use parentheses. So I got my left parentheses, and I'm doing 1 divided by 0.06, close parentheses, and then raise that parenthesis to the second power. And I get 277.777 and so forth. But remember, sample size refers to a number of people. So whenever you're counting or coming up with a number of people, we always want to round to the nearest whole. And so we'll say approximately, since we're rounding, 278. All right. We have this standard normal curve. We're told that the data is normally distributed. So we can at least draw the number line that represents this data. The mean is 72, so let's just put 72 right in the middle and build from there using a standard deviation of 10. So going to the right, I'm going to add 10, so that's 82, 92, 102. And going to the left, I'm just going to subtract 10, so that's 62, 52, and 42. Okay, well, remember the standard normal curve identifies percentages of our data that fall within these ranges. So within one standard deviation of the mean, which would be here, this is within one standard deviation, then this represents 34% of my data on either side, total of 68%. Okay, so maybe I'll just do this. If we go out one more standard deviation to 52 and 92, 2 standard deviations, this would be 13.5% of my data. So all in all, within 2 standard deviations of the mean, I've got 95% of my data represented. And then going out one more standard deviation to the 3rd standard deviation, this would be the other 5% broken up into 2.5% in this range and then 2.5% in this range. Okay, so setting this up, I would suggest you do this on your test, and then just take the ranges that you're given, find the percentage, and don't forget that the percentages that we come up with need to be multiplied by 400 because we're supposed to come up with a number. A lot of people make the mistake on this problem and they give me a percentage. Well, that's only part of the problem. You need to use that percentage times the number of people in your data to come up with an actual number of runners, in this case, with ages in each interval. So let's mark off the interval between 72 and 82. Okay, maybe a different color would be good. Just something different. So maybe I can do it down here. 72 to 82. All right. Well, that's 34%. 34% of my data in this particular case would fall within this particular range. And so since I've got 400 runners and this range represents 34% of them, then I'm going to do this multiplication. 400 times 0.34, and that gives me 136. Okay, so that's my answer for number 20. All right, looking at the next range, I want to know how many of these runners would have times that would be less than 72, or would be an age of less than 72. All right, so looking at my percentages and just counting up all the percentages that would fall in the range less than 72, that's 34%, 13.5%, and 2.5%. Or you could also look at it as that's half of my runners. Half of my runners are less than 72 years old. So I'm going to take the number of runners, 400, and multiply by 50%. And of course, that's 200 runners. Should identify these numbers. Okay, well, let's find the percentage of runners that are aged 62 to 92. All right, so let's just mark off that range, 62 to 92. So between those numbers, we have 34%, 34%, and 13.5%. So if you added all those up, you would get 81.5% of data. 81.5% of my runners are between the ages of 62 and 92. So let's multiply the total number of runners times that percentage, decimal form. Let's see how many runners that is. 400 times 0.815, and that's 326 runners. So be careful that you don't just give me a percentage answer to these types of problems. Use the percentage times the total number of people in the group to get your final answer. Okay, so here we are at this high school, and this is a probability problem where we're going to use the binomial theorem. And we're told that 30% of the students buy class rings. Well, we can then reason that 70% of the students do not buy class rings. So these buy, and these do not buy. I'm selecting 5 students at random. What's the probability that at least 2 of these 5 students buy class rings? Well, we'll start with the probability that exactly 2 buy rings. So I'm going to take the probability that the students buy rings and raise it to the second power. And if there's 5 students, 2 buy rings, that means 3 do not buy rings. Okay? And remember, we're going to multiply all of this by a combination factor, which in this case will look like this. This number that follows C always matches the failure, looking at 70%, the ones that don't buy rings, those should always match. Okay? And we'll come up with a decimal for that in just a minute. Well, the thing you got to be careful with is it doesn't say exactly 2, it says at least 2. So that means that we need to include the ones that where 3 of them buy rings, 4 of them buy rings, and 5 of them buy rings. Okay, so this would be the term of the expansion that represents 3 people buying rings, meaning 2 people do not. And here's my combination factor. All right, just continuing on, this would be where 4 people buy rings, 1 does not. All right, and then it could be that all 5 buy rings. That's still at least 2. So all 5 buying rings look like this, raising the buy rings probability to the 5th, meaning not buy rings to the 0. So let's come up with all of those probabilities, the decimal form of each one, and then we'll just add those together. So let's do 5C3 times 0.3 raised to the 2nd times 0.7 raised to the 3rd, and that's 0.3087. 5C2 times 0.3 raised to the 3rd, 0.7 raised to the 2nd, 0.1323. 5C1 times 0.3 raised to the 4th, 0.7 raised to the 1st, 0.0284. And then finally, we can shortcut this one. 5C0 is just 1. 0.7 to the 0 is 1. So really all we need to do here is 0.3 to the 5th. 0.0024. Okay, now let's add these decimals up, and that will get us to our final answer. 0.3087 plus 0.1323 plus 0.0284 plus 0.0024, 0.4718, and my answer is rounded to 3 decimal places, so 0.472 is the answer. All right, just a few more, and we're almost done. We're supposed to solve this matrix using an inverse matrix, so we need to find the inverse, which means, first of all, find the determinant. So finding the determinant of a 2 by 2 matrix means that we multiply. We multiply 5 times negative 2. Always follow this order. 5 times negative 2 is negative 10. Always subtract, and then multiply the other way. 4 times negative 3. So my determinant is positive 2. So by definition, or using the pattern, here's how you find the determinant, and then I'll actually plug numbers in. It's 1, or here's how you find the inverse, I'm sorry. 1 over the determinant, and let me just label the numbers inside the matrix. We switch places with these elements that we call A and D. So they pick up and move, they just switch places. The other 2 elements change signs. So that's the pattern that you follow when you want to find the inverse of a 2 by 2 matrix. All right, so let's put this into practice with this problem. 1 over the determinant times, if we switch places with the A and the D element, that means this is negative 2 and this is 5. And the other two don't change places, they change signs. So this would be positive 3 and this would be negative 4. Now all four of these are going to multiply times 1/2. And after I multiply those by 1/2, I get negative 1, 3/2, negative 2, and then 5/2. So this represents my inverse. And the inverse then multiplies, it technically multiplies on both sides, but I just need to show multiplying by the inverse on the right side. And it is important, it does matter that when you multiply by the inverse has to go on the left. Okay, if you switch these up, it's really going to create problems for you. So let's do some matrix multiplication. Our answer should be obviously a 2-by-1 matrix because we're solving for this XY matrix. So let's see. How do we get this top number in the matrix? When I multiply matrices together, it's row times column. Row times column. So I just match up the elements. Negative 1 times 5 is negative 5. Plus, you always add the products. If you multiply 3/2 times 10, that's 30/2, which is 15. And negative 5 plus 15 is 10. Well, that's my answer for the X of this matrix. Now let's find the bottom number, the Y. So using the bottom row, negative 2 times 5, it's negative 10. Plus, if you multiply 50 over 2 times 10, or 5 over 2 times 10, that's 50 over 2, which is 25. And negative 10 plus 25, of course, is 15. So my answer for this missing matrix we solve for is 10, 15. Okay, solve for X without using a calculator. So I want you to show me that you understand the properties. And so working on the left side of this equation, properties of logs that tell me that two logs with the same base that are being subtracted can be put together as a single log using division. And 24 divided by 3 is 8. All right. Well, using what we know about logarithms, I can evaluate this log because it literally says if you take the number 2 as a base and you raise it to some exponent, you will get 8. So what is that exponent? Remember, that's what a logarithm essentially is. It's a missing exponent that's required, in this case, for the number 2 to become 8. So the left side of this equation is going to become 3. That's evaluating the log. Okay? And so this is what I want you to show me on your test. Now let's change this log equation into an exponential equation. The base is 4, so in other words, I'm going to raise 4 to some power. Well, remember that logarithms are really exponents, and so if I'm looking at a log equation, whatever the log equals is the exponent. So in this case, the exponent that I'm going to raise 4 to will be 3. So 4 raised to the third power equals some number, which is going to give us our answer. 4 to the third power is 64. So we just solve for X using the properties of logs. Do not use your calculator. Show me that you know all the things that we've talked about when it comes to the properties of logs, how to evaluate logs, how to rewrite log equations in exponential form. And then here's our final problem. I'm solving this rational equation, and to do it, I'm going to find the LCD, and I'm going to multiply by the LCD on both sides of the equation. Well, the LCD, the lowest common denominator for 2, 6, and x is 6x. And I'm going to show that I'm going to multiply by 6x on both sides of this equation. So the way I do this is I'm clearing out these denominators. when I'm finished, I will not have any fractions in this equation. So 2 goes into 6x 3x times. 3x times 1 is 3x. 6 divides into 6x, x times, the 6's would just cancel each other, x times x is x squared. And then moving to the right side, x divides into 6x 6 times, the x's would cancel, and 18 times 6 is 108. So I see that I'm going to have a quadratic equation. I need to make this equal 0, and I'm going to do that by bringing 108 to the left side using subtraction. And I recognize that this does factor because there are factors of negative 108 that add up to positive 3, and that would be positive 12 and negative 9. So getting the factoring makes it easy to solve. My two solutions are x is negative 12, x is positive 9. And just a quick check to make sure that I don't create 0 in the denominator when I let either one of these numbers replace x, and I do not. So these are both valid answers. And so we are done. And I hope that helps you, but if you still have questions about any of these problems, feel free to send me an email, and I will do what I can to help you get ready for this test.